saw before.
Right.
And then all the wires the insulation needs to get taken off the ends. What all these bits of plastic are.
There's just a little end bits of
table,
insulation that
comes off to an exact length,
okay.
exact specifications, without ever nicks that are inside.
Sure.
So this.
Right, and then the pin goes on top and makes that connection. Is the idea, I guess.
Right. Loaded a pin. She's going to put a wiring. So she's doing stripping and pinning.
Oh, that's so neat.
And the pinning has to be done to exact specifications as well, because
of course, patients, I would imagine, are probably one of the most strenuous forms of labor because the vehicle's getting jiggled around it all the time.
Jiggled around, wide temperature differences.
Oh, yeah.
So she's pinning. And
yeah, nice meeting you.
Nice to meet you.
And then plugging is where these pins get put in the back of the plugs. So hey there. Hey, are you plugging?
I'm both. I'm putting on and plugging.
So
yeah, we just find the wire number.
So you can see this is one of the very big. Is this E450?
It is the front sled.
Front sled for E450, and the two very large connectors you've got there will get connected to the controller.
Okay,
Right, so
very
the
cool.
controller is the brain of the system.
Sure.
And the controller is actually, although it's not much to look at, it contains probably the bulk of our IP, because our IP goes into the software.
Interesting.
Right.
Makes sense, yeah.
It's the invisible smarts that makes the whole safe and efficient.
And this is taking all of the information from around the vehicle, throttle inputs, brake inputs, things like this, and sending it to the controller.
Right. Probably more routes in here for the controller, but whatever makes sense to be bundled together into a harness is here in this particular.
Very cool. And these are the connectors, of course, that we're used to seeing in the automotive world.
Right.
So everything before this space is getting the wires ready to then have the connectors put on, which then click into other things, I imagine.
Right. Now, that's built, you have to test it.
Oh yeah, how do you do that? Do you have to put it in a vehicle?
No. That would be too late. Really slow down the production side.
Sure.
Now, originally we would have two guys with a multimeter.
Just checking.
Just checking. And that got old pretty quick.
Yeah.
So we're going to go this way.
Oh, so you got a little test bench here.
So we have test fixtures for most of the harnesses we build, not all of them. So Kong here connecting in a harness that has been built, pinned and plugged. Mm-hmm. He's connecting it to the appropriate... Look, it's got the controllers here. Is this E450 front harness? Yep. So this is a harness that's being built over there. So with all these plugs, it takes a little while to connect.
Sure.
But the value is that once it's all connected, he can just type a few things on the computer here and it'll test it in a few seconds.
And so that will say if any of the pinning, any of the connections if any of those were loose or not touching, then this would solve that.
Or misplugged, switched over and put into the wrong holes in the back.
Oh, sure.
That's
It's better to happen here
by
than
the time you put pins into holes, you kind of go.
Do you do this for every harness, or do you just take of them? How does that work?
So I do it for every harness.
Every harness. Wow, that's neat.
So
That's a lot of work.
it is. So like, each to have their own test box and test. So
Wow, that's pretty wild.
Yeah, but it's absolutely what you have to do.
Yeah, it makes sense. I imagine it just leads to such much better quality. And do you find it often that some things are messed up, or is it usually pretty good to go and to check?
it just depends.
Yeah.
Each harness, sometimes there's errors. Errors are always different. It's never the same.
Right, yeah. I would imagine you wouldn't see a regular error, right? It's just pretty random. Super neat. Well, thanks for showing us.
Yeah, of course.
Once it's been tested, and it's good to which is where he puts this fabric over every linear inch, every arm on the harness. This is what he does. He's good at it.
And so this is for weather protection, wear protection, insulation in general?
Yep. So the fabric tape is used here, this kind of tape, is suited for harnesses that are going. This is an example of going to be exposed where we
That's right. We'll make it look really
where we
cinematic.
wrap it in a, which is split down the side, a plastic. You can see how slender the cable is. It's a high voltage, low current harness, and what that means is we're delivering 350 volts or whatever it's going to be for a particular accessory item. So this might be powering a power steering pump or a conditioning or something like that. We source from vendors for as electrical components. And one of the reasons we do this in an internal combustion engine environment, all these accessories are driven by an accessory belt. Well, with the electric motor, we don't have that, and so instead we buy components that don't need to be driven mechanically, but even electrically, high voltage, and that's what cables like this.
Ah, this is stuff I'm familiar with over
Right.
here. Yeah.
So these are high voltage, high current harness for a CCS combo charging port. And so this charging port has the heavy cables for the DC, cables for the AC section of, and then some signal cables that are used for the protocol and the vehicle and the charging station.
These are basically the beginning we saw earlier on, which were the
So
sleds.
this is the power sleds for the Transit 350s.
Cool,
So
and I
you
can
can
see you have cooling lines that
Yeah, so the motor is cooled, the gearbox is cooled, so there's cooling ports for that.
Oh, neat.
The inverter is cooled, so there's cooling ports for that. Ports for pretty much all the power electronics that go on here.
Yeah, you're fully thermal. You can cool and heat on demand.
You can tell an inverter and an EV because it's got two cables in, and three really what you'll see. The two cables in is the DC side, so this will go out to the batteries, and the three cables, three-phase AC that drives the motor in three phases of managed, carefully crafted, frequency varied AC electricity.
Sure.
The other thing out is these hieroglyphics we got on some of these nuts here. So nuts like this are regarded as torque. So the guys come with torque wrenches and make sure they're torqued exactly. And when they are, we paint a stripe on that runs on the shell plus the nut. So
And that way
allows
you
us-
know it's not been tampered with.
Right, you know it's not been tampered with, you know it hasn't shifted or moved, and I torqued this.
Oh, interesting. Cool. Nice.
And then we've got two dots here because somebody else comes along and does a torque audit to make sure it was torqued right. And then, because this is a critical part, there's another dots for somebody else coming along and doing a
So
torque
it's
audit
torqued
again.
3 times.
Right.
So how many of these components are critical torque components, would you say? Is it 10% of all nuts and bolts? Or
And, I don't know.
Okay.
In this case, it's pretty significant because there is a seal gasket under here,
Right, for air, for weather.
weather protection.
Yeah,
we're not getting in there, so something like that is you have to get
Right,
the
because
gasket
that could
stressed
break if that wouldn't work from moving.
Correct.
Yeah, so that makes sense.
Right. Moving on, you'll see that as we move along the production line, more components get added onto the sled.
That's a new design.
Ah, cool.
So this is one of our mechanical engineers who's been updating design on the top tier part of it,
Oh, that's so neat.
and it's currently in production. It's being powder coated and everything, so you can tell it's one of our production components. So this is the top here, and you see there's additional cooling hoses running everywhere, basically. But here, output end of the sled, these two hoses here are the ones that run out to the base.
Makes sense. So you can cool the entire loop this way, but then you also have these two that go and cool the rest of the system
Right.
separate from your power
Right?
electronics up here.
Cool it or warm it,
Sure.
because we're actively thermally managing the batteries. And here's one that even further along, it's on top, is actually nothing more than a pair of bus bars.
Just connections
Just
for high
connect
voltage.
high voltage together. So all the positives are connected together, all the negatives are
Right, don't want to mix that up.
right. And yeah, that's another area that's audited.
Right,
But
sure. Well, it'll be audited as soon as you turn on the car. You would know.
Right, there are some fuses in here for protecting some of the components. but
Oh, neat, very
Basically,
cool.
it's just two sheets of steel with everything connected to it.
That's super neat, and it honestly looks so factory fresh. I mean, when you open the hood of one of these things, and this is what you see, looks super pro, and that's because it is. Nice. It doesn't look like what I would imagine many of our viewers would think of a repower or a conversion.
Right.
It looks totally factory.
Yeah. So on the E450, we've opted to mount the motor's output flange here, pretty much right in the middle of the vehicle chassis.
Interesting.
That gives us a couple of advantages, 3 advantages. One, we don't have to try and shoehorn it with everything else.
Okay, yeah, because the E450 vans have quite a small hood area.
Yeah, because you have to encroach a house thing.
Yeah.
Which is the kind of...
Where the bell housing normally would go, yeah.
That's right. Secondly, it helps with weight distribution. And thirdly, it means that we don't need to reuse the entire chain. We just use the last piece of it.
Oh, interesting. So like where the drives normally connect, you just disconnect the first one and slide into the second.
Yeah, something. Yeah, so the shorter the drive shaft you have, the less chance there is for wobble, ripping, and so on. Good.
And this looks like a different electric motor than what you
It
use
is
on the
Yeah,
Transit.
this one's from a different vendor.
Okay, very
So
cool.
it's not, this one is not from Danfoss.
Yeah.
This is the under the hood in an E450.
So much for low to the ground.
Yeah. And you'll notice a lot of orange cables here. That's because this particular one has 3 batteries on it. Counts for 6 of these cables. And then there's a charging port, which is another pair of cables. They run to the inverter. So there should be, I think, 10 of these high voltage cables. 3, 6. Yeah, 10 cables.
And are 3 batteries the most you can spec on one of these?
Probably.
Okay.
Yes.
And how big is each? To batteries in a minute, but yeah, roughly what's the kilowatt hour capacity on the small to the large side?
So on the E450 and the Transit, packs are 43 kilowatt hours a piece.
Packs 43. So you can do like an 86 kilowatt hours, 2 packs. Is that
Yes.
what you find most people going for?
People go for on the Transit,
Okay.
although we do have one of our customers is operating very short parcel delivery services in a localized urban area. They opted to buy a single pack.
Makes sense. I'm always a fan of buying the smallest pack that fits your needs.
You know,
just
and we
from
don't want to
resources.
oversell.
Yeah,
right? For
right.
2 reasons. One is it makes it very expensive because battery packs are still the most expensive part of our solution,
Interesting.
and it hits the payload.
Yeah.
You know,
Yeah,
you
that's
add
right.
GVWR, which is the fed limit
You
on your
start
latent
eating
weight,
into it.
does not go up to
Right.
compensate for batteries.
Oh, that's so interesting. So basically, this is building A, is what you call it here?
Yes. So we're leaving building A.
And then there's this big tunnel, which I still want to set the land speed indoor record with. Conference space, and a lot of this has just been here existing from the right?
Yes.
So
Totally.
it's pretty neat how there's just so much extra space and things that you can do.
I know. We're still getting our heads around what we can do with this space.
It's the only logical solution
Yeah.
here.
So the plan is to expand floor space that we've got, right? Because as we ramp up the volume of vehicles coming through, we're going to need more space for converting vehicles, and as we ramp up the volume of vehicles, we're going to need more space for manufacturing powertrains.
Yeah, it makes sense. You're
Both
just going
are
to need
true.
more of everything.
More of everything. And so in the lease on this building, we've added 103 or 105,000 square feet,
Damn.
which will help. I mean, that will get us a long way.
Wow, this is
Right now,
it's just so big. Timon, take a look at the spaces over here.
yeah, it's a pretty serious space. Remember, you got to remember,
So is this like a test mule double decker that you have? Is this actually going to go to a customer as a repower?
both.
Oh, interesting.
This is the first actually goes to a customer too.
Very cool. You've already had one go out into the street, right? It was that really
Yes.
nice white one that went out there.
Yes, that was single decker.
Double decker.
Single
Okay,
decker.
so this is the first double decker.
First double decker, yes.
Neat. That's cool.
Some of the big techs in the Bay Area, they run fleets of these to pick up employees from hubs. Keeps vehicles off the road. The employees can do some work on them while they're commuting because they have Wi-Fi on board, and that's it for us. So we design it for a range of about 200 miles,
That's plenty, I would think.
and that works great for the purpose.
And do they just use a regular CCS charging port on this?
Yes, cool. It's the CCS Type 1 like we do.
Yeah, that's so neat.
like
And it's
one
just
combo.
such a massive machine. Can we take a walk? We can physically see on this one yet?
I don't know. They should take. Guys are probably still working on measuring, right? Because it's only been in here for a couple of weeks,
Oh, okay.
and so they're probably still
So this is very early on in the process.
at the drawing boards.
Okay.
Yep.
And do you know what year this bus is?
No.
Okay.
I think the white one was like 2014 or something, so this one may be the same or a little older.
Okay, very cool. And so I can see they've gutted this whole section here and
Yep.
planted.
Working where they need to weld and where they need to build.
This is a wild project. I mean, just the power and weight, and it's a big machine.
So the market opportunity for this, like I say, is for these employee transport, regional businesses. There's around 2,000 of those running in the Bay Area as diesel vehicles right now.
And all of these companies are these forward-thinking, potentially more green thinking. This is the type of company that would.
Desire to move to electric,
Yep.
and rather than hitting it with completely new vehicles, there's all this rolling stock which is in great shape, very comfortable.
Yeah.
Repower much less than the cost of a completely new vehicle, and in much shorter completely new vehicle, and just convert your stock to
So
electric.
it's even cheaper to existing ones, what are these buses, I guess, coaches.
Yeah.
Throw an electric system in there, maybe just change this, and you're good to go.
Right.
Rather than just buying a new one.
Yes.
That's interesting that it's cheaper to electric than buying a new one. I would have.
True.
All right, so let's take a look at this big. I guess it's called a Hino or Hino.
Hino.
Right? Hino, and is this Class 6?
This one's class, yeah.
Okay, and is because I haven't any of these done yet. Is this something that's a new project,
New
or what's
project.
the plan for this?
Yep, it's a new project. We have customers who we approach with our Chevrolet 6500.
Oh,
truck,
sure, right, yeah.
And they look at it and they say, okay, that's pretty good, but actually we prefer the Hino platform for whatever
interesting,
reasons.
yeah.
And so we said, okay, we'll do Hino.
So it was enough of an interest where it made sense to get this unit as like a test to convert,
Exactly. It's the
and
first
so
one
then
to
you'll
convert.
have the R&D team create all of the same that we see, the welding, the cutouts to fit this application.
Yes, exactly right.
And this has air brakes, I imagine. And so because you said mess with brakes, you were in air brakes with
Yes.
an EV as well?
Yes, we do. When we have a platform with air brakes, what we lose, of course, is a belt that will power the compressor that usually feeds air into the air tanks.
Sure.
So we have to do those with a secondary motor
Oh, really?
that powers a pump, an air pump.
That's so neat.
So at least on our Chevrolet configuration, we've got a secondary motor specifically for
And
air
that
brake
just
and all.
runs to keep the air topped up so that the braking system works.
Yes.
That's so cool.
Yeah.
Well, this will be a really neat project. I hope we're able to come back and show it's done and take it for a drive, because this is just, I understand the cab over approach with the Chevrolet 6500, but I could see why companies want it. It's sort of this this engine up front look. It just fits with the rest of their lineup, I imagine.
It's partly that. It's also partly vehicle features that,
Okay.
that are different. There's like safety features and other things that this has that some of the customers want.
Oh, cool. Neat. Very nice.
But naturally, we only take on a project like if there's a promise of a substantial order.
Yeah, I would think you need some serious orders for something like this to
Right.
go through.
For something like this, if it's like 50 units or something, it would be fine.
Yeah.
Because we get this all the time saying, I have a X. What
Right, and it's just like, no,
can
sorry.
we? Yeah, can't do that. We get people telling about their passenger car or their like 1998 F-150.
Oh,
or
yeah, you
something.
just have the time for that. But how
can't
much
do
do you
that.
think it costs to develop a full electric powertrain system? An exact number, but let's say for that application, is this
Well-
a $1 million project? Is it more than this? What do you?
$1 million.
Okay.
But although on something like that, it's going to use a lot of the same IP, the same control system and so on as we have GM 6500.
Oh, so you're able to harness a lot of the technology that
Absolutely.
you've used from other classicals, and you go up to Class 7?
Well, the motor coach is Class 8.
Okay, well there you go. Yeah.
We'll do a Class 7 version of the Hino at some point, and a Class 7 version of the Chevrolet probably at some point.
Right.
But,
Right, because then you just get the 7500 version of the Chevrolet. Defines it as a Class 7 at that point. Is that just suspension GVWR rating?
it's exactly that.
Okay. very cool.
GVWR rating. Some of our customers have very, very heavy payloads. You can imagine a beverage factory, right? And they're distributing soda or beer to locations in a city. Beverages are very, very super dense. It's not like it's not
Not
like
a lot of air, everything's
not like
filled.
Frito-Lay,
Yeah,
right?
right,
Where you're
right.
moving chips, where there's a lot of air, right? So therefore, there's a real trade-off between how much car you can carry and the amount of batteries you need to actually be able to move it some decent distance. And so in some cases, a customer might come to us and say, we need a Class 6 vehicle for this. You might need to think about moving up to Class 7.
Oh, interesting. Yeah. And so, how much weight do you think you take off of GVWR when you add an electric powertrain? What do you suspect? Is it a 500-pound penalty? Is it 2,000 pound?
It's more than that, because some of the battery packs are like 400 or 500 pounds a piece.
We're talking a couple thousand pounds with
Yes.
the drivetrain.
Yeah, that's right. Over this way.
Okay.
Actually, I'm going to take you here.
And so we're going past the motor production, the whole sled production, I guess I should.
Yep, powertrain production.
There we go. And being in Colorado, you have amazing views outside.
We do. We have the front range of the Rockies out there, the foothills. It's great. Yeah, Loveland is pretty much on the gateway to the Rocky Mountain National Park.
Sure.
Because there's Highway 34 that runs west from here.
Yep.
Straight up.
Ah, look at this, battery packs.
So this is what's called a pre-commissioning station. So powertrains of assembly here get tested right here. And so they get hooked up to the battery packs, and then the guy hooks up his lap and runs through a whole sequence of test operations. And that allows us to verify air is actually ready to go in a vehicle.
And able to talk about what's inside of these battery packs in terms of the type of cells? Cylindrical or
N650.
18650s, very cool. And so they're arranged in, is this just full or individual bricks that go in there, or what's
So there's a hierarchy of cells, and I can't remember, I think it's the next level up. And so it's arranged for each cell, which is 4 volts, is it? 1.7?
Yeah, usually 4 volts a cell or so.
4 volts a cell, right?
Yep.
But we want to get 350 volts out of here.
Okay.
So obviously,
so you range them in series and parallel 300, and is that so they're 350 volts up? Obviously, you'll wire them in parallel.
Yes.
So that your total system voltage is not ever 700 or 800.
Well, on the motor coach, we do 800.
Oh, do you? Oh,
by
very neat.
wiring 2 packs in series.
Okay. Right.
It's not these.
Oh, okay.
But
Interesting.
we wire them in series.
But similar shape and everything. And did you use
similar? We might see them somewhere around here.
Did you use 18650s for the coach as well? Mm-hmm. Oh, very cool.
Yep.
Neat. And
now,
then
generally, we don't go into these. We buy the packs from vendors.
Oh, interesting.
Who have built them and qualified them, and they just ship them to us.
So they just make sure they work after this test and throw them in the vehicles.
Yes, exactly.
But then your thermal management system is designed to work integrated into these packs, though.
Yep. There's a very, very tight technical relationship with the vendors to make sure that what we do is right for them, the batteries are right for us.
Oh, neat. That's so cool. And really neat. So are these upside down from what we're looking at here inside the vehicles? Or are they mounted
no, they're
this way
mounted
up?
that way up, I think.
Okay, very cool.
Pretty
And
sure
then the
of it.
little carriers like the welding station.
The battery pack manufacturer.
Makes sense.
And so we have battery management, and we have bottom balancing is a term some of you, I think that's what we're doing here. Bottom, I think it's balancing.
Okay.
But use cases, obviously we only sell to customers who have an operation that will fit with the range of the vehicle.
Right.
But that's still a huge addressable market.
Oh, massive. Yeah.
So, when we say, oh, these vehicles will go 120 miles, the first reaction is, yeah, but I need like 350. Well, not if it's a last mile delivery.
Right. Yeah.
120 is plenty.
Yeah, I think we've all kind of come to the conclusion that right now every application is suited for electric, but at least every vehicle has an application for it.
Right. Yeah, well, exactly right. We're not going to sell something that's useless, right?
Right. Yeah, absolutely. Oh, that's kind of neat. Are we able to show some of your testing stuff?
Yes, we can.
Okay, Timon, you got to come take a look at this. This, I imagine, not a production thing. This is just a test bench on wheels.
Yes, exactly that. It's cool. So this is exactly what what you say, a test bench on engineers to put together parts and pieces, the various components, some of which maybe from a new vendor. I want to prove that that component works in our system. This is a great place. You just bolt it in, connect it up, and see how it performs.
That's so cool. That is just like, that's like your top backdrop right there. That's gorgeous.
Pretty cool, yes. So over here is a vehicle that has just been decontented.
Oh yeah, we can
Looks
see
like
there's no engine in there.
No engine in it. Looks like snow melt underneath it.
Sure.
So it's probably came in A.
Yeah, for our viewers who aren't minus 15 Fahrenheit last night almost, something like this.
Pretty cold.
Yeah.
So that's what a Transit 350 looks like with nothing in the front.
It's really funny.
And we like this platform because it's very easy to tow, and the structure that's here, so you can things in and out with a hoist.
Yeah, it makes sense. I mean, I
Easy.
think the Transit's really almost the perfect vehicle for you to use, not only from a styling perspective, they're very premium, they drive, so like just that you can unbolt the front end and have full access.
Yeah, pretty much.
And then this one, obviously we don't know where it's going to or what it's doing, but essentially this will get batteries put in down this floor behind here,
Yes,
right?
that's right.
And so do they build them all in this one space, or do they move down the
They
line?
move
Station.
Right? So it gets decontented here, and some of the bracketing is put in for batteries here. The next one, which is where the sled gets put in, and then the next one is where it gets connected together, and then as it goes around the corner, it fluids and then commissioning, and final sticks and labels and ready to go out.
Interesting.
And then the E450s and 550
That
actually.
thing's massive. Oh my! This has got to have like. So this is still running off that same 350-volt battery pack system, and
This one has 4 of them.
4 of them. Yeah, this
Yep.
thing's a big dog. Wow. And it's also handicap accessible. That's really
And
neat.
that's an example of customization that we support that a lot of people wouldn't.
Oh,
right?
yeah, I would imagine.
So it's got to have the ADA lift. A lot of our customers require that. So this F550, this one's going to be for airport parking shuttle, for a commercial parking structure at an airport.
Oh, really? That's so neat. Have you ever seen that out in the wild, like just stumbled into one of your vehicles?
The trouble is, you wouldn't.
How would you know? I mean, I guess on the E450s on the side,
Yes.
right? And where do you charge the
Looks like
transits
where
from?
the transits. Well, see, the transits use the same fuel flap.
Combustion equivalents. Have you tested that?
Not personally.
Oh, it sounds like it should be a good challenge.
No, that would be something you'd be all over. I
Yeah,
know.
absolutely. I think from a practicality standpoint, I don't think you'd lose any drivability in tippiness or anything like this with the systems. It should handle better because they're super low.
It probably does. Yeah.
Yeah. Thanks so much for joining this very long and in-depth tour of Lightning e-motors. Let us know what you think about this vehicle segment. Should we cover more medium-duty electric vehicles? I certainly hope you enjoyed it. I had a blast learning more about the company, and keep an eye out for our coverage during our weekend with the Lightning e-motors Transit. Hello and welcome to Inside EVs. Today we are touring a factory called e-motors where they build medium-duty electric vehicles. That's like these transits behind me all the way up to a Class 6, Class 7, and even motor coaches. Taking us on the tour today is Dan Bennett. Dan, thank you so much for the tour. We appreciate it.
You're welcome.
See today.
Everything.
Everything. So from even like wiring to electric full vehicle assembly behind us. It's going to be a long video, right? For in-depth. Yeah, super fun. So Dan, thanks for willing to us on the tour and also loaning us a vehicle because we're going to have a ton of fun over the next week driving vehicles. That's going to be in a separate video. Let's get started and show us start to finish of your. Welcome to the Lightning e-motor. Before we get into the full factory tour, let's go over how this video is going to work. If you're watching on YouTube, you will see embedded chapters into the video. Because this is an over 1 hour, I've broken it up into sections in case you want to jump from area to area. There are 2 particular sections with audio issues, something where you may have to turn up the volume a little bit on your side. Really apologize for this. However, most of the video is totally fine. Just be warned that you may have to adjust audio levels midway through just for a few minutes. Dan, you got to tell me before we get into the factory, what is this crazy blob?
Pretty unique looking, right? So this is actually a history piece from when the company was first started.
Oh, interesting.
So the company started in 2008 with two guys, Tim Reeser, who you'll see later in this video, and they wanted to compete for what's called the Automotive X Prize of 2010.
Okay, and this is some sort of challenge, I
Yes,
imagine?
exactly. So the prize is for various things, $1 million for the first person or first company to do whatever that challenge was. And the challenge for 2010 was to do a SPA that could do 100 miles to the gallon.
Oh, interesting.
Right. This vehicle is under the Saturn,
Oh, cool.
complete with the original engine, I think. What makes it a challenger for the prize, though, is a hydraulic hybrid regenerative braking system on board.
Okay, so imagine for a second, you have some sort of, every time you slow down, you're able to pressurize this hydraulics.
That's exactly right, yes.
Okay.
So it's based on an accumulator, which is a tank that has a base inside, it's neoprene rubber, nitrogen gas. And then when you touch the brakes on this, a pump engages on a clutch, which pumps hydraulic fluid into that accumulator. That causes that bladder to collapse, get squashed down, much like compressing.
Oh, sure,
And
absolutely.
so the pressure rises because you're compressing the gas, and then stored energy, like compressing a spring.
Right.
And to accelerate again, we reconfigure the valves, and now the pump turns into a motor, so that as that fluid comes out under pressure in the vehicle.
And I imagine you must have a way to disconnect it if you wanted to
it's a
entirely.
clutch.
It's a little clutch. Very cool.
Right.
And is this useful? I can't imagine on the highway. It's got to just be in the city because
Exactly.
you're slowing down a lot.
It all depends on stopping and restarting you do. So
Okay.
every time you stop, you store energy, and every time you start, you redeploy that energy that you stored when you were stopping. The whole point of it is that on a normal vehicle like this, every time you slow down and stop, you're just turning energy into heat, and that's what friction does for you. I mean, it's useful to slow down and stop your rear end,
But it's
rear end
wasted
someone.
energy.
It's wasted energy. So from an energy perspective, you've spent good money on the fuel to it. Now you have to throw away all that and the associated energy and slow down and stop.
Sure.
Right. So it was a regenerative braking system, and this was kind of its test bed.
And then, yeah, that turned into some other applications that you guys built, not in huge numbers though, right? You built retrofit kits?
Right.
Okay.
So as this developed, somebody advised the two guys that the addressable market, hydraulic hybrid technology, as a retrofit module for trucks and buses.
So rather than them building this as a car, which is really
so the car
difficult
was
to
dropped,
do.
it's now a museum piece.
Right.
And we turned our attention to the medium and heavy duty vehicles with a hydraulic hybrid solution.
And that seems like such a great solution for especially lottery, where there's a ton of stop and go. Why did you eventually transition away? And of course, our viewers know we're talking about electric vehicle. When did that transition happen and why?
Well, transition happened in 2017, and there was really nobody was buying the hydraulic hybrid.
Oh, interesting.
We had a number of competitors at the time, and one by one they threw in the towel. They kind of exited the market. And you'd think on the surface, oh good, wonder, but really it was just a non-validation that
That the technology is just not that useful.
Right.
Yeah.
It was so difficult to quantify the benefits of it, because for any given vehicle it depends on how the driver behaves when he's stopping and starting, and how many
Right.
stops and starts there are on the route, and all the rest of it, which meant that we could not say we'll get 28% fuel savings.
Right, because
and
who knows?
70% emissions reductions. Couldn't say any of that, right? Because it's range, which they may or may not see.
Right. That's
And the world was at the time beginning to turn its, and so the company pivoted at that point. That's the way we've been ever since.
right. So when we go through the factory tour, you use no longer hydrants at all It's full battery electric systems from the ground up.
Yes.
And I'm super pumped to go see what all this is about. But I have to ask you before we go over here.
Yes.
First off, I love the Ford Focus Electric. They were sold in such small numbers. I think only in California. We're not in California, so what's there?
This was what you euphemistically call a donor vehicle.
A donor vehicle. Okay. So you harvested the high voltage
We
components?
harvested high voltage, especially the batteries.
Yeah.
Yeah. And the reason was that at the time that we started scoping out how to do electricity, getting hold of road-going battery packs impossible.
Oh,
For
just
ones
the source
twos.
and even from a cost perspective, it must
Right.
have been astronomical.
Right. It was cheaper and easier to lease a bunch of these vehicles, and they're out in the parking lot, lined up out there, all gutted.
All brand new, never driven Ford Focus
Right.
Electrics, just with powertrains completely missing.
I don't even think we took the motors because it's too small a motor for what we need.
Right,
It's
just took
just
the battery.
the battery, some of the supporting components. Yes.
Wow, that is so. That's why there's a whole bunch of these little Focus Electrics in the
Right.
parking lot. So you're going to just say, "We're really sorry. Good luck."
Well, pretty much. The lease is coming to an end pretty soon.
Yeah.
And I think it's safe to say we're not going to get the deposit back.
So funny. I love that early days story. I think it's I think that's such a cool thing. But now it's time to go, I guess, this way over three. So
do that.
what are we going to do? Are we going to look at from the smallest components to large? What's the best way to run through the whole place?
Well, so we're moving on to the north side of the building, which is where all the assemblies and manufacturing for the powertrains.
Okay.
Later on in the tour, we'll go into the south side of the building where they're putting into vehicles. Of course, that's where the vehicles actually become EVs. But we're going to see everything from really small components, pins that are going onto wires, right through to the battery packs that are producing metalwork that holds it. So we'll see everything.
And the biggest thing here for me is it's just so incredible quiet. We're in a factory and there's no noise.
Right.
It's very nice.
You'll find more noise on the vehicle side because they get out the impact wrenches.
The real fun.
On this side, it's pretty quiet. Okay.
Dan, you got to explain. This looks like a graveyard.
Well, it's not quite a graveyard because these motors are not dead.
Oh, interesting. All basically fresh motors that come out of the vehicles that have been dropped off.
Exactly. So let me explain to you kind of our main business. So vehicles come to us almost fresh from the Ford factory. They usually come through a dealership. They're less than 100 miles on the road.
And then it's in the E450s, right?
The Transit 350 HD, the Class 3 Transit, and E450, and there are some others, but those are kind of our biggest sellers right now. So they come here and they're gasoline, and so what we have to do is we have to take out the gasoline engine and the exhaust system and the fuel system. That's a process that we call decontenting.
Sure.
And that takes about 90 minutes, I think. It's pretty quick to get that out.
That's amazingly
Especially
fast.
for the Transit, yeah. They just put it up on lifts and bing, bang, bong, it's done.
That's crazy.
But of course, that does mean that this hardware is here. These engines, we do have a couple of brokers who come by and buy them from us periodically.
Oh, interesting. So they'll have a second life opportunity,
Yeah.
of course, for like
Exactly.
a fleet vehicle, for example, that might have problems. This could go in and replace that.
Totally, yes. So
Very neat.
that's kind of our model. So about how this model works. First thing is, bear in mind that although from a technical point of view we're taking the internal combustion and electric drivetrain, the drivetrain is in there and fully commissioned before the customer, the end user, ever registers it.
Oh, so it's technically an EV.
It's an EV at the time that the government first gets to learn that it's on the road.
That's
Therefore,
so
it's a
cool.
new EV, right?
So it qualifies for tax and
Yeah, tax incentives, and there are other incentives in different states and municipalities and so on, regions. California has a fairly good program for quite a lot of money if you qualify.
So is it the case where they go to the owner, first registered EV, and so it's the same as buying any off-the-shelf EV at that point?
Of course it is.
That is so cool.
I mean, let's underline that point. So California, as you know, is more rigorous a vehicles come onto market than ever, right? And so in a seller vehicle, you need an order from CARB, which is the California Air resource board.
Yep.
And so we have to know that for every one of our vehicles, it has an associated EO signed department chief that allows us to sell legally in California. Now there's separate EOs from one department for new vehicles, 2 EOs for retrofit products. So for all of our new vehicles, we get a new vehicle.
Oh, that's
so
cool.
as it reaches the streets of California, it's regarded as a When it comes to retrofit, we do also have a thread of our business where we take vehicles that have already been on the road, like a diesel motor coach, for example, and turn that into an EV.
Then that's the retrofit.
And that's a retrofit, and that has a different kind of executive or associated with it.
Huh, that's so neat. It's amazing that you're able to do, but it makes sense because you're getting the cars fresh. But don't it be better eventually to get them just as without engine from Ford?
Yeah, we do. That's what's called a glider.
Okay.
So just an airplane without an engine in it is called a glider. Right? It's
Makes
the same
sense.
thing for fleet vehicles like this.
Okay.
So yes, we would love Ford to provide us, but it's a matter of scale.
Okay.
Right, so for Ford to completely a new line of vehicle manufacturing and bill of materials and everything to produce gliders, if our volume is too.
Makes sense. Yeah. So once you get volume up to, what do you think that number is roughly? You don't need an exact number, but
We think it's probably around 1,000 a year.
1,000 a year, and then Ford can just start sending you, basically they bypass, they just don't put in their engines. You get to buy the cheaper cost, of course. And probably, or at least hopefully, then you don't have all of this waste. But of course, you're still going to make some money from selling these.
We don't a whole lot.
Right, yeah, probably not.
Yeah, but we do make some.
And do you think it's probably not a whole lot also because these are all brand new vehicles and new vehicles come with warranties, so there's not as much demand for these engines? But in like 5 years, people are going to want.
Right, sure. Yeah, you're exactly right. And not only that, but the Ford Transit line from, I think it was Ford Transit, or maybe E450, went from a 10-cylinder engine to an 8-cylinder.
Right.
And so the engines are brand new, so for the only vehicles that they're applicable to
are warranted vehicles.
Are warranted new vehicles.
Yeah,
and so they'll
sense.
be sitting around for a while.
Yeah.
But they do at least get taken off our hands.
Well, I'd like to swap one in my Smarties. But so this is basically the past. Why don't you show us a little bit about the future?
All right.
But
before we do,
yeah,
I just draw our cameraman to the shot here of the side of the engine. So this is a standard engine from Ford. We've got the engine here in its tram. Just have a look at the overall shape of it. This comes out of a Ford Transit. I think this is a Transit one. Could be an E450, but you get the general idea. And now I'm going to bring you over to here, where there is a set of electric power for transit vans.
It's basically crate motors.
Yeah.
That's so cool. So how many of these do you have here? 1, 2, 4, 5, 6, 7. You have 10 of them almost.
10 ready to go, yes,
Yeah.
and you'll see more being manufactured. So, so as I say, the Transit is kind of our biggest volume vehicle at the moment, the Transit, so we have to make sure these are ready to go into vehicles. So if you have a look at this, and first of all, I'll draw your attention to the shape of it. It looks very familiar, and the reason is that it just slides straight into the engine bay, exactly where the engine and transmission came out of.
And are the mounting points pretty much the same, so you don't need any
identical.
patience? Really? Yeah, that's great.
So on that topic, here's something that a lot of our followers may not know. Ford has a program called QVM.
Okay.
Qualified Vehicle Model.
Sure.
And that's a program that Ford runs for thousands of upfitters across the country and probably the world. So anyone who takes a Ford E50 and puts a body on it, they have to be Ford QVM certified.
Vehicle warranty.
Right. Because then Ford, they make sure they don't drill holes in the wrong place in the chassis. They make sure the weight distribution's okay. Ford has a more elite program, EQVM, which is Qualified Vehicle Modifiers for alternative fuel.
Interesting. So they actually have a whole program to verify this type.
It's like 4 or 5 companies on there, not many, maybe only 3.
And
I'm not sure.
are you guys
Totally.
EQVM?
Yes,
yeah.
we are.
So basically, someone can buy this. You basically can warranty the motor components.
You're exactly right.
But the vehicle, like if your headlight stops working, all Ford. You just
All
bring
Ford.
it right to a Ford dealer.
Yep.
Oh, that's
so
neat.
Ford sends agents here. every quarter or every half year or something to carefully audit what we're doing.
Yeah.
Make sure that we're not screwing up the brakes, not screwing up the weight distribution, not screwing up the CAN bus or anything like that.
Right. So you guys actually operate on the vehicle's existing CAN bus system.
We do.
Oh, that's so cool.
Interface directly to it.
That's
and
neat.
that's really useful for things like for monitoring the driver's controls.
Yeah,
and
because you don't have to redo anything.
Right.
That's super easy.
So yeah, very, very deep level of integration like that.
Cool.
It actively audits us for EQVM certification.
So tell me more about this crate. I'm going to call it the crate section. I'm not sure what you do, but it's
Sled.
A sled. Okay. So tell me more about your sled. You have obviously power electronics up front, an electric motor here in the center. I guess a reduction gear back here.
Yes.
But explain.
So the traction motor is this cylindrical component in the middle there to a rear drive axle.
Okay, that makes sense. So you
Right.
don't have a motor on the axle itself. It goes through the existing factory drive shaft, or do you have to create a
Shaft.
So this endpoint is the exact same distance from the end of the transmission output shaft. So
Yes.
it just matches up. So you don't have to do anything.
Correct. You're right. You
It's
slide this
amazing.
thing in and put mechanically you're coupled.
Useful for different length of wheelbase vehicles, especially transit. You can get in different configurations. It'd be not, you don't even have to worry about all that.
Well, worry a bit because we specify a minimum wheelbase because we've also got to fit battery packs under as well.
Oh, okay, that makes sense. So
Right.
your ones to get the electric.
Yep.
Yeah.
So the only convert is the 350 HD, which is high roof, extended body,
These, yeah,
Yes.
the dually, they look great.
which is great because we're the only people doing that van platform.
Interesting.
And in fact, Ford is coming out with an electric transit van next year, but it won't be the Class 3.
Oh, so it's just going to be a lower duty.
It'll be smaller ones.
Yeah.
It'll be, I think, the Class 1 and the Class
Correctly, there are no passenger.
no passenger
So
version
you can
from
have
Ford.
one with like 10 seats in it or whatever it is. They're not going to be able
Right.
to offer that.
Yeah,
It's a good competitive advantage. That's neat.
totally. Yeah.
Yeah.
Other key components we've got here is the electronics box. It's a bit hard to see, but it's way down at the bottom. So the inverter is the power electronics that interfaces the side of things, which is what comes from the batteries,
Sure.
with the AC by the motor.
Of course.
So it's a variable frequency drive, which is what's needed to change speed on the road.
Absolutely. Otherwise,
Um,
they'd all just at whatever speed you have it set to.
Right. And in addition to that, it also supports regenerative.
Oh, that's great. Can it do even one pedal type driving as well?
Yes.
That's so great.
That's right. You foot off the pedal, feels like you've got aggressive engine braking because you've got aggressive engine braking.
And then you can
But
also
in this
calibrate
case-
this for other things too, right? So, for example, like if you're on a route, you can coordinate it to not just roll
Yes.
backwards.
Yep. We'll come to that in just a minute.
Okay.
Regenerative braking, remember our history, which was all about regenerative braking.
Sure.
So you can bet that we have put a lot of emphasis on optimizing the regenerative braking efficiency of our. I think we have in the industry.
Really?
Mhm.
Okay, that's neat.
Model the heck out of it. We optimize it. So regenerative braking, which is regenerative braking,
Of
is,
course,
right?
yep.
So,
Yeah.
but the motor basically does double duty as a generator to slow the vehicle, push some charge back into the batteries.
And do you think there's a measurable increase in the system because of that?
Absolutely.
Yeah.
Yeah, because we don't touch the braking system. They're still the factory friction brakes on the wheels. We do not touch those because then the OT gets very upset. So those are exactly as came out of the
Right,
Ford
so you
factory.
keep related stuff factory.
Yeah.
And then all you're
Plus,
doing is
we,
changing the
plus
way.
things, like the traction control and other things, ABS, we make sure that that's working
Very
so
much
that
needed.
we don't screw up any of the things, and that's one of the things that EQVM is about.
Okay, yeah, that makes sense. Very cool. We are joined here with Tim Reeser, who's Lightning E. So, Tim, tell me a little bit about what goes on, just a general overview of what you guys do in the factory.
Certainly. So Lightning E-Motors focuses on commercial medium-duty vehicles. So what you'll see in the factory is a wide things from small delivery vans, or small in our definition is a 3, so over 10,000 pound delivery van, all the way up to big motor and double-decker motor coaches throughout the factory. What makes us unique to all of that in one factory. So our ability to a building block of software and a building block of hardware and create a very eclectic set of customized highly segmentations that meet people's requirements and needs. And one of the things you'll see that is different about commercial vehicles is it is highly customized. A lot of people think about delivery vehicles and they all look the same when they see them come by their vehicle, and in fact they're all very different. The same thing when you think about, for example, an RV or about an ambulance. Again, all very different. What's underneath the vehicle is different. What's up of the vehicle, the high voltage aspects are different. So we specialize level of customization across this factory to support this customized market in a cost-effective way.
Yeah, I mean, you've in so many different use cases for the vehicles. What primarily would you say is like the bread and butter that you see a ton of repeat, or is it all just?
I would like it to be a ton of repeat, but it really is very different. So I'll give some examples. We've done quite a few shuttles there, but even the shuttles will range from a 15-passenger van-based shuttle all the way to a passenger motor coach. Yeah, so it's a double-decker motor coach, and it's a lot of fun. It has a bath. All the complexities, it sounds, a lot of people think of electrification like I've put them in a battery and I'm done, but when you stop and think about, even the small ones might have special video connections to look at temperatures on passengers for COVID, or might have special situations for how they're seated, and each of those are different for each of the coaches. So we think about that passenger space, and we like it a lot, but throughout COVID it has been constrained. When you think about campuses, whether it's a school campus or a large employer campus, they aren't trained to been doing pre-COVID. So then you step back and say, what about ambulances? Well, obviously they are still very popular today, and that hasn't changed with COVID. Now, delivery has accelerated with COVID. A lot more van and trucks out there with last mile delivery, and we don't think that's going to back off. We think people have become accustomed to delivery, but even there's some uniqueness. We're working with customers on grocery delivery, and that's refrigerated